All right, everybody. Good afternoon, evening, morning, whatever you're watching this. This video is going to make a foldable that you're going to put in your composition book that will look like this. And we have linear functions. We're going to focus on explicit and recursive equations with an example. We have exponential functions we're going to focus on. And then we have quadratic functions. That's a new word. Quadratic functions, which we're going to focus on. This video, I think today, is only going to have you make the foldable setup, and then it's going to focus on the details in linear functions, and then the next one will be exponential, and then we'll go to quadratic. So today, you're going to make the foldable first. So take a piece of binder paper and make it look like this so that it is holes on the top. And if you want to use white paper, you can if you have any. I'm going to adjust my thing a little bit. If you have white paper, then you can use white paper. I'm using the binder paper because it's probably what you have, and it gives me some nice lines to work with. So you're going to fold it in half, crease it down, and then you're going to actually fold it now into thirds like we did your name tents. So you're going to put the fold I put on the bottom, and we're going to fold it in thirds, so make a little burrito, and then squish down so they're about the same size. So mine's not exactly the same size, you can see, but it's close enough. So then put it back so the holes are on top, and we're making a little book type thing. So this part here where my hand is, this is going to stay connected. These folds we're going to just cut until we get to the center right there. So I'm going to cut, this part stays connected, this part I'm going to cut. And you're just cutting until we get to the fold, and that's it. So now you have this part. This will get glued into your composition book, so don't worry about anything yet. But when you're done, you can put this in the composition book so you don't lose it, tape it, glue it, whatever. So we have one flap, the middle one we can open, and the bottom one we can open. So the top one is what you learned about in 8th grade actually, and then again you focused on it in Math 1. And these are linear functions. And linear are lines. That part always tells me it's a line. So we either have positive slopes going up from left to right, negative slopes going down, or we have the flat slope of 0. So those are the 3 types of lines you have. The second are your exponential, X-P-O-N-E-N-T-I-A-L, exponential functions. And so these are either quickly increasing, and they actually forever go this way, or they start up high and they go quickly decreasing. They can actually even go flat, 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 then decrease this way. Or they could actually go up quickly and then level off. Just depends on the type. You usually, I think, work with this type in quadrant 1 or quadrant 2 are the 2 that you focus on. And then the third are quadratics. Q-U-A-D-R-A-T-I-C. And these look like smiley faces or frowns. So either smiley face, and I'm going to draw little eyes, smiley faces, little eyelashes in there, or they're frowns. So I'm going to draw sad eyes with some tears coming down. Eyelashes are hanging down, not so happy. So they're either sad or they're happy. I'm going to talk about how you know which is which. So please make sure you put your name. I'm going to put my name. Make sure you put your name and then put what block you're in, just in case you don't have this in your composition book and it gets lost. And I'm going to put today's date that I'm making it, which is August 13th. You can put whatever date you want that you're watching this. So there's that. So now we're going to go into linears. So you need to have two colors. I'm going to have a green, and I think I have a blue I was planning on using. Sorry, let me get my colors out. I thought I had them out. I got to find them again. So I'm going to be using green and blue as my two colors. You can use them if you'd like, or two other colors. We're going to be consistent with them. So with linear functions, we have the two types of equations that we talked about before. We have explicit, and we have recursive. And I think that might not be dark enough for you. So I'm going to actually go over this and tell you to never do your work in pen, but I need you to be able to see this. So I'm going to be writing in black pen whenever I'm writing so you can see better. This is a new document camera, so I'm learning what you can see or not see. Oh, that looks like it probably is better. Explicit and recursive. And so we have, let's go more exact, explicit equations and recursive equations. And so in our table, our linear function, we're going to have a table. This should be straight line. And in our table we have x and we have f of x. Down here we're going to actually give ourselves room for an example. So I'm going to do this. And we're going to actually, with this example, put our explicit and recursive equations for this table. So this table, I'm going to give you -1 for x is 4 for f of x, 0 is 6, 1, 8, 2, 10, 3 is 12. So this is our table that we're going to use for this example. And so the explicit equation, we're going to start with that. The explicit equation is y equals, and this is what everybody's like, mx plus b. And then they're like, oh, but I don't know what m or x are. So m, I'm going to go over in my blue. M is in blue. M is also, if I write it in this way, I can say it's also f of x. Gives me the same thing. M, I'm going to just write it out in blue to start. X plus, and I'm going to have B be green. There. So mx plus b. This also actually here could be f of 0. So sometimes you see f of 0 as like your starting point. And so m is known as your slope. It's also known as your growth, or it's known as the first common difference. That'll make more sense when we talk about the exponential. And b is also this b, which could be written as f of 0. And this is your y-intercepts. This is your, also, which is the point 0, comma b, where it crosses the y-axis. And if we're talking about pictures, then it's the figure 0. And so if I look at my table, and I want to examine the growth, I am going from 4 to 6. I am adding 2. And again, I'm adding 2. And again, I'm adding 2. So my growth in this case is 2. And so that's going to be my m. So we can put over here, in this example, m equals 2. And the y-intercept is when x is 0. So that's 0. So f of x is 6. So that's my y-intercept. So I can say b equals and b is the value when x is 0. So b equals 6. And so now if I want to write my expression or my equation down here, I have f of x equals, my slope is m, so I have 2 times x plus, and my y-intercept is 6. So there is my explicit equation. And we talked about the recursive equation a bit in class, except for I think 6th period we never had a chance to because of our fire drill. But for the recursive equation, we have f of x equals f of x minus 1. And then we just look to see what are we doing from above to the next number in the f of x. So what are we doing to each value? That's your growth. We are, in this case, we're adding 2, but you can say plus m. And this m is the same thing as it is over on this side. M is your growth, also known as your slope, also known as the first common difference. Same thing. And so this f of x minus 1 means this value of f of x. So here's f of x. So f of x, let's say this is 6. So x is 0. So that's what this x is right here. So f of 0 equals what you get when you put 0 in here. So 0 minus 1 is negative 1. So when x is negative 1, what do you get for f of x? You get 4. And what do you have to do to get to f of x? You have to add 2. So that's what this is saying. This is just saying the number above it. What are you doing to get to the next one? So we're adding 2. So in class we talked about this. These actually have 2 important parts. You have what are you doing, and then you need an address or a place where you need to put it on the grid. So we have f of x equals f of x minus 1. This case we're adding 2, so plus 2. And then any point you have in this table, we need to say what it is. So f of what value of x. So you can choose any of those values on the table or that you know. I like to always choose the first value. So x of 1, just because it's easier usually. So when x is 1, f of x, or f of 1, equals 8. So you need both parts to be a true recursive equation, because the slope of 2 just means you're going to go up 2 and over 1. So you have this line, but where does that line go? Does it go here in your graph? Does it go down here? Does it go way up there? Does it go over here? I don't know where it goes in my plane, but this number tells me, oh, you have to have the point x is 1, y is 8. So I know it has to go through a certain point. So the exponential, we're going to not do anything with, because this has been 13 minutes and I want to leave you with that. I don't want to do more than 15 minutes and I can't do that. So on your composition book, I want you to now, actually, in your composition book and then in Edpuzzle, you're going to do another problem where I give you a table and you need to show all of your work to write in the explicit equation and the recursive equation. So you're going to be typing it in for me, or multiple choice depending on how I make it. So you need to make sure that you can do this. Remember, m is your growth, that's what are you doing here, and b is your y-intercept, which is right there. Notice the y-intercept is not in the recursive equation. It's not over here. It's only important over here. You could put it over here if you said f of 0 equals 6 as this point, but you don't have to. So hopefully you have this done when you come to class on either Wednesday or on Thursday. Have a good night, good afternoon, good rest of the day, whatever today is. Bye-bye.